Alright, state the zeros of the following functions. Y equals 2x, x minus 1, x plus 2, x minus 2. Okay, well the zeros are easy. X, to make this 0, x would have to equal 0 because of this part. 1, negative 2, or 2. Done. Alright, this one here, you should be able to just know that this is going to be x equals negative 3 halves, 5 quarters, and negative 7. But some people might like proof that the 2x plus 3. How do you make that equal to 0? Well, that's easy. You just take 3 away from both sides, and you divide both sides by 2, and x equals negative 3 halves. So that's the, if you're unsure of yourself, like where the 3 goes and where the 2 goes, and you don't want to be all memorize-y, that's a way to do it. So 4x minus 5, if we want that to equal 0, you're going to say, well, 4x has to equal 5. Add 5 to both sides. Divide both sides by 4. X has to equal 5 over 4. So that's how you would do that. All right, for part C, your zeros are 3. And there are 2 of them there, so I like to say order 2. That way I know when I'm graphing it, if it's not gonna go through at 3, but it'll bounce off and come back because it's order 2. Negative 5 and 4. Those are both order 1. Okay. Part D. Okay, part D. X is equal to negative 6. This one's order 3. Oh, yeah, order 3. Which means if we were to graph this at negative 6, we would do something like slow down and go through. It wouldn't just go through normally like that. Kind of slow down, and it won't bounce off. What else we got? We also have a 5 halves. There we go. Let's go part E. Part E. Right here we have a x equals 0. Would make this thing 0. And, well, we're going to have to factor this. This is a difference of squares. So this is actually, so I'm going to rewrite it. Y equals negative 5x, x minus 3, x plus 3. And so 0, 3, and negative 3 are my factors. So if I were to graph this, end behavior is negative, so it's going to go like this. You got a plus 3, minus 3, and 0. So it's going to go yoink, boink, doink. There you go. All right, part F. We got a 0 at negative 5. And, oh, we're going to have to factor this one. So let's do that. Y equals x plus 5, x squared minus 4, x minus 12. That's a quadratic. We can handle that. X plus 5. Let's see. This is 2 numbers that multiply to give negative 12 and add to give negative 4. That would be negative 6 and positive 2. So x minus 6, x plus 2. And you can double check by expanding this to see if it equals this. Anyway, so your x values that make this 0 are negative 5, positive 6, and negative 2. All right, 2A. All right, so here we don't have any y variable. We just have x variables, and we're asked to solve. So let's just shove everything to the left right away. So we got 3x cubed minus 27x equals 0. Now factoring, first thing you want to do is take out a common factor. So there's a 3 and an x that go into both of those, and you're left with x squared minus 9. Well, that's convenient. Now we have a difference of squares, so we can say this is x minus 3, x plus 3. So we know that this equals 0, right? So x must equal either 0, 3, or negative 3. Part B. 4x to the 4 equals 24x squared plus 108. Of course, bring everything to the left. It makes life so much easier. And do it by subtracting. everything from the right. Minus 108 equals 0. Common factor, you get a 4 in everything. There's an x in the first two, but not in all of them, so we can't take out an x. So we got x to the 4 minus 6x squared minus 27 equals 0. Okay, I'm going to do this in a kind of a cool way. Imagine that, let's let p equal x squared. Then we have, this is actually 4 times p squared, because x squared is, x squared is just equal to p squared, which is equal to x to the power of 4. So x to the 4 is p squared, minus 6 times p minus 27. That equals 0. Well, this is just a normal quadratic that we're used to seeing. So that only works because we have a 4th degree, a 2nd degree, and a 0th degree. There's no 3rd degree or 1st degree. So it's just, when I see stuff like that, I like to take a shortcut and do this. So 4, this is going to be p minus 9, p plus 3, and that's because negative 9 and 3 add to give negative 6 and multiply to give negative 27. All right, and now I can put my x squared back in. This is 4x squared minus 9, because p is x squared. X squared plus 3 equals 0. So you got 4. X squared minus 9 is x plus 3x minus 3. And x squared plus 3 actually cannot be factored. And I'll show you a graphical reason why. X squared plus 3, well, this is y equals x squared. Y equals x squared plus 3 is just raised by 3. And this graph never touches the x-axis. So if it never touches the x-axis, then it can't be factored, because there are no factors that'll let you equal 0. So that's how you know it can't be factored, is if it just never actually touches the x-axis. So this is fully factored, and this x squared plus 3, there are no x's that'll give you 0. So there are only actually 2 zeros on this in this quadratic, or sorry, this quintic. So to solve this, x just equals 3 or negative 3. Now, if you didn't happen to notice that this was 4th degree, 2nd degree, 0th degree, you could have just tried numbers, like tested numbers. So you got 4x to the 4 minus 6x squared minus 27. Of course, the numbers that would have worked are 3 and negative 3. So let's try 3. 4 times 3 to the 4 minus 6 times 3 squared minus 27 equals 0. 4 times, this is going to be 81 minus 9 times 6 is 54 minus 27 equals 0. And so, yeah, 0 equals 0. So that is true. 3 works. So we could also have said, okay, well, so then x to the 4 minus 6x squared minus 27, we could divide that by x minus 3, because we know that x minus 3 is one of the factors now. And you'd get what? Oh, you'd have to put, let me do that better. This is for people who really like to work hard. 0x to the 3 minus 6x squared plus 0x minus 27. So I'm just going back to this guy. We said that x equals 3 is one of the zeros, so x minus 3 must be one of the factors, and now I could actually factor it out. So I'm going to say x to the 3, should be able to go through this quickly by now. 3x cubed minus 6. I guess this is going to be plus 3x squared. This is going to be 3x cubed minus 9x squared. This is going to be 3x squared, so plus 3x. And this is going to give you 3x squared minus 9x. It's going to give me, so 0x minus 9x is plus 9x, and this is going to give me plus 9. And that will give me a remainder of 0 in the end. All right, so then you're going to have to test out a -3 and do the whole routine again. And as you can see, it was so much easier just to realize that this is a 4th degree, 2nd degree, 0th degree, and replace it with p for x squared, and then bring it back to x squared. It just made life easier for me. All right, part C. All right, for part C, there is an x in all of these. So we're going to say x times 3x to the 3 plus 5x squared minus 12x minus 20. Trust me, always look for a common factor. It makes your life easier. I like that it equals 0. I don't have to pull everything to the left. All right, now we have to find something that'll make this equal to 0. Let's try -2. So 3 times -2 cubed plus 5 times -2 squared minus 12 times -2 minus 20. This is -24 plus 20 plus 24 minus 20. Yeah, that equals 0. Okay, that's good news. Let's use that. Okay, so we know that x times x minus 2, so, oh no, -2, so x plus 2 is another factor. Let's find the other factor. 3x cubed plus 5x squared minus 12x minus 20. Let's get rid of that x plus 2, so we got 3x squared cubed plus 6x squared negative x squared, so negative x squared minus 2x, negative 12 minus 10x, so this is minus 10, and you got minus 10x minus 20, and sure enough it's a 0 remainder. Okay, so it's 3x squared minus x minus 10, that equals 0. Now we have a quadratic. That should be pretty easy to factor. x plus 2, let's see, two numbers that multiply to give -30 and add to give -1. Well, that's going to be -6 and +5. 3x squared minus 6x plus 5x minus 10 equals 0. So you break this -x into your two different x values, and then you could break this up. This is going to be 3x times x minus 2 plus 5 times x minus 2. That equals 0. So this is going to be x plus 2, 3x plus 5, x minus 2. All right, there I have, if you look on, I believe it's day 2, I have a pretty in-depth explanation of how these steps work in the comments section. There's someone who asked me about it, and I have a pretty deep explanation of it. So go to day 2, I think it is, and look in the comments, and that should be helpful if you don't understand this. Anyways, we need to solve, so x must equal 0, -2, -5/3, or +2. Done. Let's do part D. 10x cubed plus 26x squared. This one already looks easy. Number 1, I don't have to bring anything to the left because it equals 0. Number 2, I see that there's an x, and is there a 2 in all of them? 2x in all of them, so it's 5x squared plus 13x minus 6, and so we already have a quadratic. We have a lot of practice from grade 10 and 11 with those. Let's see, two numbers that multiply to give -30, which is 5 times, and add to give 13. Okay, I feel like 15 and -2 will do the job. Right? They multiply to give -30, they add to give 13. All right, so I can rewrite this as 5x squared plus 15x minus 2x minus 6, which means I could pull out a 5x from these two, x plus 3, and I could pull out a, let's see, minus 2 from these, and you get an x plus 3 equals 0. Let's erase this. And so this is 2x, 5x minus 2, x plus 3 equals 0. So x is either 0, 2/5, or negative 3. Done. Okay, E looked like it's going to be easy. We got 2x cubed plus 162 equals 0. Obviously, you pull out a 2, so x cubed plus 81 equals 0. Now we just have to find how x cubed plus 81 can equal 0. Well, that means x cubed is going to have to equal negative 81. So that means x is going to be the cubed root of negative 81. And that's about 4 point something. So that is our answer, the cubed root of 81. 2 will never equal 0, so you don't have to worry about that. The only way to make this equal 0 is for x cubed plus 81 equals 0, which means the cubed root of 81. So part F, 2x to the 4 equals 48x squared. Bring everything to the left. Always do that. 2x to the 4 minus 48x squared equals 0. Let's take out a 2x squared. You got x squared minus 24 equals 0. And you're going to have, so x, let's do one more step here. X minus root 24, x plus root 24 equals 0. So x equals 0 from here. And 0 is of order 2. There are 2 of them. Comma root 24, comma negative root 24. There you go. All right, we need to find the zeros of this function. So just when this equals 0, like 2, 17, 23 equals 42. So this should be easy. Let's try negative 1, so that will help with this negative thing. So we got 2 times negative 1 cubed minus 17 times negative 1 squared plus 23 times negative 1 plus 42. Hopefully these are all negative. Yep, so negative 2, negative 17, so minus 17, there's a plus, so minus 23 plus 42. Of course that equals 0. All right, so that's good. We know that negative 1 is one of the zeros. Let's see what the other two zeros are. Minus 17x squared plus 23x plus 42. X is negative 1, so x plus 1 is one of the factors. What do we got? So 2x squared will give me 2x cubed plus 2x squared minus 19x squared. So minus 19x here. Negative 19x squared minus 19x is going to be 42x, so plus 42, and 42x plus 42, and there's a remainder of 0. So we know that this can be rewritten as y equals x plus 1, 2x squared minus 19x plus 42. All right, let me find two numbers that add to give negative 19 and multiply to give 84. All right, I think negative 7 and negative 12 should work. So we can say this is, here, let me erase this stuff here. All right, we're going to y equals x plus 1 2x squared. I'm going to break this negative 19 into negative 7x and negative 12x. So plus 42. Y equals x plus 1. This, there's an x in both of these. 2x minus 7. And there is a 6 in both of these, so minus 6.
Maybe send me a photo of your scientific calculator as well.
2x minus 7. And so y equals x plus 1, x minus 6, 2x minus 7. Let's get rid of this.
Just shout if you need anything.
And so x,
you can stick around or you can leave. It's up to you.
if we're determining the zeros, so
just these
y equals 0 at x equals negative 1, positive 6, or positive 7 halves. Write a polynomial equation whose roots are the zeros of that function. Okay, well, how about 2x cubed minus 17x squared plus 23x plus 42 equals 0. That should do it. Or I could have said 2x cubed minus 17x squared plus 23x equals negative 42. That would work. Alright, question 4. Explain how you could solve x cubed, well, all this equals that. Okay, so one method is I could graph y equals x cubed plus 12x squared plus 21x minus 4, and y equals x to the 4 minus 2x cubed minus 13x squared minus 4, and find all of the x values where both graphs are equal in height. So you can see here, this red one is the cubic. It goes down, up, down. It'll go off to infinity over here. The blue one is this quartic. That goes down, up, down, up. Notice they both end with, their end behaviors are both going up towards positive infinity because they both have leading coefficients that are positive. Positive 1, positive 1. So where do they cross? They cross here at 7 when x is 7. It doesn't matter what the height is because this height is the y variable. We made up y variable. This original equation doesn't have any y variables. We just let this side equal this side, and so we let this side equal y, and then we let this side equal y, and then to find when they're the same, we're just looking to see when y is the same. Well, y is the same when x equals 0. Or sorry, x equals 7 here. So at x equals 7, that's when these two sides are both equal to like 1,000 and something. But the fact of the matter is that's when they're equal. Another spot, at 0, they're both equal to negative 4. Well, we can see that. When I plug in a 0, this is going to equal negative 4, and so is that. At negative 1, they're both equal to some value that I can't see because my eyes are bad. And at negative, looks like negative 6. Oh, no, sorry, negative 3. So at negative 3, they're both equal as well. So those are my solutions. And if you check it out, if you plug in a negative 3, a 0, a negative 1, and a 7 into this side and this side, they're both going to give you the same answer, and so that will be correct. All right, method number 2 of solving this, my favorite method, is just to first manipulate this and bring everything to the left. So you're going to have negative x to the power of 4 plus, this is plus x to the 3 plus 2, so plus 3x to the 3. You got 12x squared plus another 13, so plus 25x squareds, 21x's, that's it, so plus 21x's, minus 4 plus 4 is just 0, so it equals 0. And now I can graph y equals negative 4x to the 4 plus 3x cubed plus 25x squared plus 21x, and then graph y equals 0, which is just the x-axis basically. And so I just have to find the zeros of this. So let's show that graph. All right, so here we see this is just y equals negative x to the 4 plus 3x cubed plus 25x squared plus 21x right here. And y equals 0 would just be a straight line across here. So where do those two cross? Well, it's going to be the exact same solutions as this quartic and this cubic. The x values will be the same. But where they cross is simply where the x-intercepts are for this guy. All right, so you got right here negative 3 comma 0. You've got negative 1 comma 0 it looks like. You got 0 comma 0. And you got 7 comma 0. So the same solutions, x equals negative 3, negative 1, 0, or 7. To me, this one's way easier because I only have to graph one thing and find the zeros. Here, I would have had to graph two things and then kind of find where they cross. All right, I'm going to show you a third method. Third method is similar. You start the same way, except you don't worry about the actual graphs. Okay, and you're going to say, oh, sorry, I'm going to erase this. Sorry for taking so long here, guys. All right, let me factor out an x. You got negative x cubed plus 3x squared plus 25x plus 21. Let's see if I could find something that's going to equal 0. Let's try 0. Oh, we already have that. Let's try negative 1. By the way, I already know which ones are going to equal 0 because I already know all the solutions, but plus 3 times negative 1 squared plus 25 times negative 1 plus 21. This is going to be 1 plus 3 minus 25 plus 21, and that equals 0. Oh, what do you know? X plus 1 is a solution. Let's try another one. Hey, let's try maybe 7. Negative 7 cubed plus 3 times 7 squared plus 25 times 7 plus 21. Oh, what do you know? That equals 0. So I know that x minus 7 is another one of the factors. Let's try negative 3. Negative 3 cubed plus 3 times negative 3 squared plus 25 times negative 3 plus 21. And that equals 0. Oh, what do you know? X plus 3 is also a factor. And so x equals 0, negative 1, 7, negative 3. That's another method. Another method was just to find one of these guys and then do negative x cubed plus 3x squared plus 25x plus 21. We could have divided by x plus 1, and we would have gotten a quadratic, and then we could just keep doing, you could factor that quadratic, and that quadratic would finally factor, obviously, into x minus 7, x plus 3. So that would it would actually be the negative of that, so it would be like negative x minus 7 and x plus 3, but same. Anyways, those are like 4 different ways of solving it. Determine the zeros of the function algebraically. Verify your solutions using graphing technology. All right, so let's say f of x equals I can take out an x from here. So x times 2x cubed minus 11x squared minus 37x plus 156. All right, let's see what makes this guy equal to 0. Let's try f of 3. So this is going to be 3, x is 3, 2 times 3 cubed minus 11 times 3 squared minus 37 times 3 plus 156 equals 3 times, this is 2754 minus 99 minus 111 plus 156 is 3 times 99 and 1 is, so 200 minus 210 and plus 210. Yep, that's 0. Is 0. Okay, so f of 3 equals 0. That means that one of the factors is x minus 3. All right, so let's see what the other factors are. Let's get rid of this. So you got, let's do 2x cubed minus 11x squared minus 37x plus 156. Get rid of the x minus 3 and see what you have left. So this is going to be 2x squared. That gives me 2x cubed minus 6x squared. This is negative 5x squared, so minus 5x. 5x squared plus 15x. Negative 37 minus, so minus 40, so minus 52x. That's going to be minus 52. And that's negative 52x plus 156, and a 0 remainder. That's good news. So f of x equals x minus 3, and 2x squared minus 5x minus 52. All right, we can erase this. Find another number that goes into that, or just factor the quadratic. Either way. Another number that goes in is negative 4. That'll make this 0. But it's pretty easy to factor a quadratic. You just need two numbers that multiply to give negative 104 and add to give negative 5. That would be negative 13 and 8. That'll work. So this is going to be, let's just do this down here. 2x squared minus 5x minus 52 is the same as 2x squared minus 13x plus 8x minus 52, because these two add to give negative 5. I'm going to take out an x from the first two. And you got 2x minus 13. I'm going to take out 4 from the second two. 4. And you got 2x minus 13, and so that is equal to x plus 4 times 2x minus 13. So this is x plus 4, 2x minus 13. Okay, I might as well do the thing that I like the best. I like taking the 2 out. So you're going to have 2x, x minus 3, x plus 4, and this is going to be x minus 13 over 2. I like that because that way it's really easy to find my zeros, 13 halves, negative 4, and 3, and also the end behavior is really obvious. It's going to end positively. All right, so what does this ask? Verify your, okay, so determine the zeros. Therefore, the zeros are 0, comma, 3, comma, negative 4, comma, 13 halves. And let's do graphing technology. All right, here's the graph of f of x, and as you can see, the places where it equals 0 is at negative 4, 0, 3, and 6.5, which is the same as 13 over 2. And so those were the correct answers that we did algebraically. Number 6, state the zeros of the following functions. All right. This one is going to be x when x is 0 or 2, and that one's order 2, or -5. The zeros here are at x cubed equals 1. Let's see, x cubed equals, so x cubed plus 1 has to equal 0. So x cubed has to equal -1. So x is that equals the third root of -1, which is just -1. All right, so this is going to be x equals -1 or 17. All right, part C, you got, so this one right here, x squared plus 36, that's x squared plus 36 will never equal 0. I'll show you. X squared equals -36. Well, that means x equals a square root plus or minus square root of -36, but you can't take the square root of a negative number. So, but 8x minus 16, that's no problem. You got x equals 2. That's not a problem. 8x minus 16 equals 0. You got 8x equals 16, and x equals 2. All right, let's go to D. X can equal 0. Always look for that one. That's the tricky one, and that one is order. Gosh, I covered it up. Hold on. Let's do this. So x equals 0, and that's of order 3, because there are 3 of them. That's like basically x minus 0 to the power of 3. 2x plus 4, so x could be -2, and this one, x squared, has to equal 25, so x equals plus or minus 5, so x equals -5 or 5. There we go. All right, here. In this factor, x equals 0. This one here, I got to factor that guy. That's going to be x minus 4, x plus 3. And so x equals 4 or -3. And the last one, f, you got x equals -1. And I guess I got to factor this now. So two numbers, so it's going to be x plus 1, x plus 1. So it's going to be -1, -1, and -1. So -1 order 3. There you go. All right, number 7, factoring to find the roots. So let's find something that makes this expression equal 0. All right, numbers that go into 90. Let's try 5. So we'll do 5 cubed minus 8 times 5 squared minus 3 times 5 plus 90. And that's equal to 125 minus 200 minus 15 plus 90. That equals, let's see, 0. Yay, so we know that x minus 5 is one of the factors. Let's find the other one. X cubed minus 8x squared minus 3x plus 90 divided by x minus 5. We got x squared, which is x cubed minus 5x squared, -3x squared. So we got minus 3x, -3x squared plus 15x. That's -18x, so minus 18, and this is going to have a 0 remainder. All right, you can finish that off if you want. I just did it in my head. Minus 18, and so there's x minus 5, x, let's see, two numbers that multiply to give, so minus 6 and plus 3. There you go. They -6 and 3 multiply to give -18 and add to give -3. All right, so it says determine the roots. Oh, I guess the roots are x equals -3, 5, and 6. Let's go to part P. x to the 4 plus 9x cubed plus 21x squared minus x minus 30 equals 0. All right, let's try x is 1. You're going to get 1 here plus 9 plus 21 minus 1 minus 30. Yeah, that's 0. That's perfect. So we know that x minus 1 is a factor. So x to the 4 plus 9x cubed plus 21x squared minus x minus 30. And we're going to divide by x minus 1. And you get x to the 3. X to the 4 minus x to the 3. 10x cubed. Get plus 10x squared here. 10x cubed minus 10x squared. You get 31x squared, so plus 31x. Multiply by x minus 1, you got 31x squared minus 31x. This guy minus that guy is 30x. And so you got plus 30, and you got 30x minus 30 and a 0 remainder. Okay, and so you got this is times x cubed plus 10x squared plus 31x plus 30. All right, let's erase this. Find another number that goes into this to make it 0. I don't know. Let's try negative 2. So negative 2. Yep, it works. Okay, so negative 1, x plus 2 is the other one. So 1 and negative 2 worked. So we're going to go x cubed plus 10x squared plus 31x plus 30. By the way, that negative 2 worked because I did negative 2 cubed plus 10 times negative 2 squared plus 31 times negative 2 plus 30, and it equaled 0. So you could do it on your own if you want to see that for sure. X plus 2. You'll also see that there's a remainder of 0 down here, so that's another way to convince you that the negative 2 worked, because when I divide by x plus 2, the remainder will certainly be 0. So you got your x squared. That gives you x cubed plus 2x squared. It's 8x squared plus 8x. This is 8x squared plus 16x. This is going to 31 minus that, so 15x. It's got plus 15. That's going to give you 15x plus 30. And your remainder is 0. Perfect. So this is x squared plus 8x plus 15. Once I get this erased, I can say that, let's see, two numbers that multiply to give 15 and add to give 8 are 5 and 3. And so we got, oh, by the way, these all equal 0. X minus 1, x plus 2, x plus 5, x plus 3 equals 0. So x equals 1, negative 2, negative 5, and negative 3. Those are the roots. All right, 7c. 2x cubed minus 5x squared minus 4x plus 3 equals 0. So we got, let's try x at x equals negative 1. We got 2 times negative 1 cubed minus 5 times negative 1 squared minus 4 times negative 1 plus 3. And that certainly equals minus 2. It's going to be minus 5, minus 7. So plus 4, plus 3, and that does equal 0. So x plus 1 is a factor. Let's get rid of this garbage. So this is going to be x plus 1 times something equals 0. You guys like long division, so we'll do some more long division. Minus 4x plus 3 divided by x plus 1. You're going to get 2x squared. 2x cubed plus 2x squared minus 7x squared. So minus 7x here. Minus 7x squared minus 7x. Then you got your plus 3x plus 3. And you're going to have a remainder of 0 down here. All right, so we've got 2x squared minus 7x plus 3. Let's erase this garbage. Two numbers that multiply to give 6 and add to give negative 7. So that'd be negative 6 and negative 1. So 2x squared minus 6x minus x plus 3 equals 0. X plus 1 is, let's see, 2x comes out of those ones. X minus 3, and you got minus 1. X minus 3 equals 0. X plus 1, 2x minus 1, x minus 3 equals 0. So x equals negative 1, 1/2, and 3. Those are the roots. Let's try part D. These are actually pretty difficult questions, honestly. 2x cubed plus 3x squared. I'm just going to go minus 5x minus 6 equals 0. I just like everything to the left, as you should. 2, 5, so let's see if this is, yeah, so negative 1, you got, this is going to be 2 times negative 1 cubed, which is negative 1, so negative 2. This is going to be plus 3, negative 1, so plus 5, that's 8, minus 6. Yeah, so negative 1 works. Let's get rid of this. This is going to be x plus 1 times something equals 0. I'll just skip ahead to the end of this division so you don't have to watch me do it. Alright, I got 2x squared plus x minus 6. And gosh, two numbers that multiply to give negative 12, so that's going to be 4 and negative 3. So x plus 1, 2x squared plus 4x minus 3x minus 6 equals 0. Get rid of this stuff. And x plus 1, you got 2x. Oh, sorry. This will be x plus 2 minus 3x plus 2. And so it's x plus 1, 2x minus 3, x plus 2 equals 0. So x equals negative 1, 3/2, or negative 2. Done. Part E. Let's get rid of this. 4x to the 4 minus 4x cubed minus 51x squared plus 106x minus 40 equals 0. Bring everything to the left. Alright, looks like when x equals negative 4, this stuff equals 0. So we know that x plus 4 is a factor. I did just plug in negative 4 here. You'll see that the whole thing equals 0. So x plus 4 is a factor. Let's find the other factor. I'll do long division. You guys don't need to sit here and watch. Alright, so I did the division of x by x plus 4, and I got 4x cubed minus 20x squared plus 29x minus 10. Alright, I need another number that'll give me 0 here. Let me try 2. So if I do 4 times 2 times 2 times 2, that's 8 times 4, 32, minus 2 times 2, 4, minus 80, plus 58, minus 10, we got minus 90, plus 90, so this is equal to 0. So sure enough, x minus 2 is also a factor, because 2, if x equals 2, makes that 0, so there must be a factor where when x equals 2, you get a 0. That's the one right there. Alright, so let me do the division. 4x to the 3 minus 20x squared plus 29x minus 10 divided by x minus 2. I won't make you guys wait through that. There you go. So this is x plus 4 times x minus 2 times 4x squared minus 12x plus 5. Now we can erase all this. There we go. And let's make that a little nicer. Now we still have to factor this guy. It looks like we're going to have 4x squared, two numbers that multiply to give 20, add to give that, so negative 10, negative 2, minus 10x minus 2x plus 5, 4x squared. Oops. Let's take out a 2x from those two. 2x is 2x minus 5 minus 1, 2x minus 5. So this is 2x minus 1, 2x minus 5. All right, so this is equal to x plus 4. These should all equal 0, right? X plus 4, x minus 2, 2x minus 1, 2x minus 5. And that equals 0. And so, let's get this out of the way. X equals negative 4, positive 2, 1/2, or 5 halves. Oh my gosh, this is so tedious. That was just E? All right, let's do F. I make you do F, then I should be able to do F. All right, F. Now, I know I can rewrite this as 12x cubed minus 44x squared plus 49x minus 15 equals 0. Okay, I got to find a number that goes into here and makes it 0. And I don't see anything really that obvious. Now I know to look for. If there's nothing really obvious, then I start looking at this last number. But usually that's when this first number is 1, right? I usually take out that first number, x cubed minus 44x squared plus 49x minus, oh shoot, this is going to be over 12 minus 15 over 12 equals 0. So really that last number that I'm looking at is negative 15 over 12. So I know that if I were to do this, my 3 factors, those last numbers together are going to multiply to give negative 15 over 12. So I'm going to start testing some numbers that might be more likely to multiply to give that. So I'm going to try even like negative 0.5. Let me try that. So that times negative 0.5. So that's going to be 12 times 0.2 times negative 0.125 minus 44 times 0.25 plus 49 times negative 0.5. Yep, that actually does equal 0. You'll need your calculator for that. So I know that negative 0.5, so that's negative 1/2, and then the other two are going to have to multiply to give negative 15 over 6. So those will be interesting numbers to find out. Let me try negative 5/3, or let me try positive 5/3. Positive 5/3, and it's 12 times 5. Plug that in, and it does equal 0. And then the other one would have to be positive 3 halves, right? Because this has to be positive 15 over 6. So positive 5 over 3 and positive 3 halves and negative. So the final answer is going to be x plus 0.5, so 1/2, x minus 5/3, and x minus 3 halves. And so x is equal to negative 1/2, 5/3, or 3 halves. That was a bit of a cop-out. I think I'm going to, you know what, I'm just going to wait. If anyone watches this video and wants me to do it the long way, I just, once you find this negative 1/2 here, I would do the long division, and then I would end up with a quadratic, and then I would just do the quadratic formula to find the other two. I will do that if someone actually, writes me an email and say, hey, Portal, can you do 7f the long way? All right, 9a. Let's just find a number that will make this equal 0, and negative 2 does it. So we know that x plus 2 goes into that. Let's see what else does. X cubed minus 6x squared minus x plus 30 divided by x plus 2 squared plus 2x, that's x cubed plus 2x squared. Alright, so I did the division. You got x squared minus 8x plus 15. And so two numbers that multiply to give 15, 1 times 15, and so it's negative 5 and negative 3. So this is going to be x plus 2. Oh, by the way, this equals 0. X minus 5 and x minus 3 equals 0. So x has to equal negative 2, 5, or 3. Done. All right. Let's go part B. All right, I know I can factor out an x. 9x to the 3 minus 42x squared plus 64x minus 32 equals 0. Let's try a 2. 9 times 8, 72, minus 4 times 42 times 4, 168, minus 168, plus 128, minus 32, and that equals 0. Alright, so x equals 2 is a solution. So that means x minus 2 is a factor. Let's get this erased. So this is x minus 2 times, this is going to be 9x squared minus 18. So it's going to be minus 24x. That's going to be plus 48, so another d plus 16. And that's going to equal 0. Alright, fine. I'm going to do this through decomposition. So 9 times 16 is 144, and so negative 12 and negative 12 multiply to give 144 and add to give negative 24x. Well, negative 24. Alright, so I can say that this is x. Here, let me erase that. This is negative 12 and negative 12. X minus 2. 9x squared minus 12x minus 12x plus 16. This is decomposition. X minus 2. Let's go 3x times 3x minus 4 minus 4, 3x minus 4 equals 0. So this is x minus 2, 3x minus 4, 3x minus 4 equals 0. So x equals 0, 2, or 4/3, and the 4/3 is order 2. So if I were to graph it, order 2, just so you guys remember, leading coefficient is positive 9, so it goes up like this. It's going to go through at 0, it's going to go through at 2, and it's going to go through at 4/3. and so it's going to go through, but it's going to bounce off this and go up that way. All right, part C. We got 6x to the 4 minus 13x cubed minus 29x squared plus 52x plus 20 equals 0. Alright, I checked off camera and I put a 2 in here and the 2 worked, and also a negative 2 worked. So let's start with the 2. So I know that we got x minus 2 goes into there. I'll do the long division down here. 6x to the 4 minus all that, and you got your x plus 2 over there. So 6x cubed goes here. I'll finish the whole thing off without you guys. Alright, I got a 0 remainder, so that means I probably did it right. So it's a 6x cubed minus x squared minus 31x minus 10 equals 0. Like I said, I noticed that minus 2 also worked. So I'm going to do x minus 2, x plus 2 is the next one. So I will take this new part, this factor, and I will take x plus 2 out of that. Just give me a second here. So here we got 6x squared minus 13x minus 5, that equals 0. Let's erase this. And we still have to decompose this quadratic right here. And so let me do that. So I got 6x squared minus 13x minus 5. I want two numbers that multiply to give negative 30, which is negative 5 and 6, and they have to add to give negative 13. And so those numbers would be, let's see, negative 15 and 2. Right? They multiply to give negative 30, and they add to give negative 13. All right, so negative 15 and 2. Okay, we can erase all this, and we are done factoring. We've got x minus 2, x plus 2, 3x plus 1, and 2x minus 5. That equals 0, so x must equal 2, negative 2, negative 1/3, and positive 5 halves. Okay. All right, that's part C. Let's do D. Almost done here. X to the 4 minus 6x cubed. And you get your plus 10x squared, but you also have minus 1x squared. So plus 9x squared minus 2x. And this minus 2x is going to be plus 2x, so that's just equals 0. Well, this is actually not so bad. Let's take out an x squared. And then we have x squared minus 6x plus 9 equals 0. Two numbers that multiply to give 9 and add to give negative 6 are negative 3 and negative 3. So this is x squared, x minus 3, x minus 3 equals 0. And that means that x equals 0, and that's order 2. And 3, also order 2. Just to remind you guys how that would be graphed, the leading coefficient is positive, so it's going to go upward like this. 3 and 0 are your zeros, but they're both order 2, so it's going to like bounce off, and go upward like that. There we go. Alright, looks like we have an open-topped box that can be created by cutting these 4 squares out of a box. So this is my box that doesn't have a top on it. Determine the dimensions of the squares that must be cut to create a box with a volume of 1008. Alright, so when I'm going to fold here, 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 and here, and so that the length is going to be, it even tells you 30 minus 2x, the width will be 20 minus 2x, and the height will be x. Alright, so the volume is equal to x, 20 minus 2x, 30 minus 2x, and that is equal to 1008. All right, I want to bring everything to the left, which is going to kind of screw up my factored form, so I'm going to have to expand this. So let's say 20x minus 2x squared, that's these two together, times 30 minus 2x minus 1008 equals 0. Let's keep expanding. So 20x times 30, that's 600x. 20x times minus 2x is minus 40x squared. Negative 2x squared and 30, so minus 60x squared, and plus 4x cubed minus 1008 equals 0. Let's get this in order. So you got 4x cubed minus 100x squared plus 600x minus 1008 equals 0. 4 goes into all of those, so let's bring this up here. So 4x cubed minus 25x squared plus 150x minus 252, and that equals 0. All right, let's try some numbers. Let's try 3. So 3 cubed is 20. Let's go 27. 3 squared is 9. 9 times 25. So 225. So minus 225 plus 450 minus 252, and that is, so you got negative 477 and positive 477. Yeah, that equals 0. All right, so get rid of that. X equals 3 works. Let's factor out the x equals 3. So we got 4 times x minus 3. Factor out the x minus 3, I should say. X squared. That's going to be minus 3x, so minus 22. It's going to be minus 0, so that's going to be plus 66x. So plus another 84. That equals 0. 252. Yep, that works. Now we have to factor this guy. I'm just going to use the quadratic equation. So since this has to equal 0, that means x has to equal negative b plus or minus the root of b squared minus 4ac all over 2a. So x equals approximately, calculator, 17.083 or 4.917. All right, let's just make sure that those are actually permittable here. So we can actually kind of say this is like x minus 3, x minus 17.083, x minus 4.917 equals approximately 0. Those are a bit rounded. So that means the side lengths, let's do for x, let's do x. So I got x equals 3, comma, that, comma, that. Those are the 3 answers. For x equals 3, we have a length of 24, right? 30 minus 3, 2 times 3. And we have a width of 14, and we have a height of 3. For x equals 17, we have a length of negative, that would be a negative length. So this one is inadmissible. That's impossible. You can't cut it. That would mean these cut squares actually go beyond like each other. It doesn't make any sense. So this one is inadmissible. What about 4.9? Is that in the right range? Yes, you got 4.917 here. This would be, yeah, that would be fine, and that would be fine. Those would be good. So our 2 answers are, therefore, was it determine the dimensions of a square that must be cut to create a box with that volume? we could have a length of, let's see, 30 minus 6, so 24, width of, we got 14, and height of 3. And if you actually do the math, 24 times 14 times 3 equals 1008. Or we could have, here, let's do this. I'm going to do this way over here. Length of 30 minus 2 times that. So length of 20.166 approximately, width of 10.166 approximately, and a height of 4.917 approximately. And if you multiply these three together, you also get 1008 approximately. These guys have been rounded. So we actually have two answers. We kind of have three answers, but one is inadmissible. Like you can't have, this would end up with a negative length and a negative width. Anyway, so two answers for that question. All right, the distance of a ship from its harbor is modeled by the function that where t is the time elapsed in hours since the departure. Factor the time function. All right, we're good at factoring. D of t equals negative 3 t can come out of everything. So you got t squared minus t minus 6. Negative 3 and 2. So you got equals negative 3 t minus 3 t plus 2. All right, that's part A. When does a ship return to the harbor? So the distance of the ship from its harbor. Well, we know that t, when does t equal 0? So when does the distance equal 0? That's either when it's leaving or when it's coming back, or when it has come back, all right? So when will that equal 0? So for B, we're going to say 0 equals negative 3t minus 3 t plus 2, which means t either equals 0, 3, or negative 2. Negative 2 is inadmissible, right? Because this is t is the time elapsed since the departure from the harbor. That would be 2. Is that in hours? Ship modeled by that function where t is the time elapsed in hours. Yeah, so that would be 2 hours before they left. So that's definitely not when they come back. 0 is right when they're about to leave, so 3 must be when they came back. So when does the ship return to the harbor? 3 hours after departure. Now I say inadmissible. Like if this thing does model like it says, then actually we know that 2 hours ago it was at the harbor, and then it left, and then it came back, and now we're at the harbor again, and it left and it came back a second time, I guess. So 2 hours before it left the first time, it must have left another time. Or you could just say inadmissible. It only counts at 0, depending on how you want to look at it. C. There's another 0 of d of t. What is it, and why is it not relevant to the problem? Oh, we just talked about that. The negative 2 is x equals negative 2 is another 0. But it happens 2 hours before departure. It's crazy. I bet you there are a lot of people who don't even know how to read handwriting, so I probably shouldn't be doing that. Anyway, I was talking it through anyway. So D, draw a sketch of the function just between 0 and 3. Okay, well, I'm going to draw the whole thing and then just erase the rest. All right, so I got my zeros at 0, 3, and, 0, and negative 2. My leading coefficient is negative, so I know it goes like this. And they're all order 1, so it goes here, here, here. There we go. But now I need to erase it so that it only is between 0 and 3, and then I'm just going to double check and see, does it say that it is allowed to equal 3? Yep, and equals 0. Yeah, so it's less than or between, but it's allowed to be equal. So these are all good. Estimate the time that the ship begins its return trip back to the harbor. That's an interesting question because I think most of you would say, it's going to be between these two. And I wouldn't really have a problem with you guessing 1.5. That would be fine with me because only in calculus will you actually be able to tell me where this top spot is. So for our purposes, the time, so you can just say, therefore, the ship begins its return after about 1.5 hours. And that's a fine answer. So the actual answer is like 1.7863 or something like it's like really, it's a weird spot. It's actually over to the right a bit, but 1.5 is a fine guess for you guys. All right, this should be fun. Determine algebraically where the cubic polynomial function that has zeros. All right, let's start right there. Let's call it f of x. It has zeros at 2, so x minus 2, at 3, x minus 3, and at negative 5, so x plus 5. I don't know the a value yet, but I know the rest of it. Has to pass through 4 and 36. All right, so I know that f of x is equal to 36 when x is, so f of 4 is equal to 36. So this is a times 4 minus 2, which is 2. 4 minus 3 is 1. 4 plus 5 is 9. So 36 equals a times 18. So divide both sides by 18. And we got a equals 2. So I actually now know f of x is equal to 2, x minus 2, x minus 3, x plus 5. Now we just have to find out when it has a value of 120. So when does f of x equal 120? So 2, x minus 2, x minus 3, x plus 5 has to equal 120. All right, well, I guess let's do this the long way algebraically. It does say to do it algebraically. All right, we're going to bring everything to the same side. So we're going to say, let's expand these guys. We're going to say 120, we'll leave that out for now, equals 2x minus 4 times x squared minus 3x plus 5x, so plus 2x minus 15. Now we got, let's multiply this guys together. Got 6 operations to do. So you got 2x cubed. We have minus 4x squared plus 4x squared. Oh, those go away. And we got minus, let's see, minus 8x, and this is a 15, so minus 30x, so minus 38x, and you've got plus 60. That's 120. Let's bring that 120 over. So you got 0 equals 2x to the 3 minus 38x plus 60 minus 120, so minus 60. I can divide both sides by 2. That'll make it nicer. So you got 0 equals x cubed minus 19x minus 30. All right, looks like a negative 2 will probably give me 0. Negative 2 cubed is negative 8. Minus 19 times negative 2 is positive 38. And then minus 30. So, yep, that'll give me 0. So we can say 0 equals x plus 2 times something. Let's go x, it's going to be x squared, so that's plus 2x squared, so minus 2x squared, minus 4x, so minus 15x, and minus 30. There we go. Of course, I just did long division, but I kind of just did it in my head, so you guys can go ahead and do long division there. Two numbers that multiplied to give negative 15, so negative 5 and positive 3. So this is 0 equals x plus 2, x minus 5, x plus 3. So x must equal negative 2 or 5 or negative 3. Those are the three spots where it's going to have a value of 120. Just for fun, because we are learning about advanced functions, might as well kind of do a little graph of this. Oh, it's not y, is it? It's called f of x. F of x, I named it. Alright, so we have zeros at 2, 3, and negative 5. And we have a leading coefficient that is positive, so it goes through there, and through there. I know the y-intercept, or the y-intercept, or the f of x intercept, I should say, is negative 2 times negative 3, which is 6 times 5, which is 30. So 60, it goes through here at 60. And at negative 2, so this should go up higher. This is going to go like this. Negative 2 comma 120. At 5, it's going to also be 5 and 120. And at negative 3, oh, so it goes through here and then back through here. Negative 3, 120. There you go. So our graph is going to look like there you go. And these are the three places that where it will go through 120.